All right, I got 5 minutes, so what am I going to tell you in 5 minutes? Well, validating Kubernetes images are what they claim to be. So first, what we're going to do is I'm going to give you a 30-second crash course in Sigstore. Sigstore is an open source project under the Linux Foundation to make sure that signing is easy. And what that allows us to do is verify that software hasn't been tampered with, essentially. So one of the things that we want to do with that, which gives us, there are some bad anti-patterns probably from the years of using GPG keys to sign. And one of those things that we've kind of accumulated over time is that we don't verify actually who signed things, we just verify that they're signed. And so when we go to sign things with Sigstore, it's going to actually attach our identity to it so that people can verify that after. So what we want to do is we want to be able to run cosign verify and then actually pass in who issued the certificate, what their email address was, and then we can validate that things actually came from where they intended to be and that they haven't been tampered with. So what does this tell us about signatures in Kubernetes? Well, what a signature can actually tell you is who signed it, that it hasn't been tampered with or altered since it was signed, and potentially any claims made. So claims could be an SBOM, claims could be a vulnerability scan. Those are things that people are saying about what's included inside. So Chainguard, for instance, we build things from source. We might make claims about the salsa level of the how it was built, right? The process for which it was built. So applying this to Kubernetes, let's take a look at the Kubernetes 128 changelog. This actually lists a bunch of images that are included with the release. You can click on that link on the slide and see that table. You can also grab that list from the SBOM. So the SBOM is in that little curl command there, and that's going to give you a list of images. Now what do we do? Well, let's take a look at one image. So we're going to use cosign. We're going to verify that things actually came from the Kubernetes release team and the Kubernetes CI system. So they're using Google to authenticate, and they actually have a CREL trust identity associated with that. So we're going to run cosign verify. We're going to pass the image in there. It's going to tell us some things about the verification process. So it's going to tell us that all the claims were validated. So it was able to verify that nothing's been tampered with, and then it came from the Kubernetes CI system. Now we can also take a look at the output in standard out. And if we want to get really funny, don't worry about that command. The slides will be available. You can actually pipe that all the way to OpenSSL. Using OpenSSL, you can actually look at the certificate and what's inside it. You'll notice a few key things here. So one, the X.09 certificate that was generated and signed with, it was used just for code signing, you see, under key usage. So nobody can take the certificate and nobody can run a web server, for instance, with it. You can also see that the identity was signed and who issued that identity, so that's Google. So they might make other claims about how the person authenticated, two-factor authentication, multi-factor authentication. If I had more space on the slide, you'd also see that the certificate was only valid for 10 minutes. So the certificates in Sigstore are very short term to close attack vectors. One other cool thing that you can do is verify the actual image contents. So there's a project called BOM, which a coworker at Puerto, he's on the Kubernetes release team. He developed this BOM tool, it's under the Kubernetes project, to actually parse out the SBOMs. So it's an open source tool, you can just go install it, and the link's there in the bottom. And what it'll do is it'll actually parse out the SBOM that came from the Kubernetes release team. And if you go back a couple slides, it shows you how to get the SBOM right here. It's just a curl from sbom.kates.io. And if you wanted to parse that to the BOM tool, it'll actually try to make sense of the thousands of lines of SBOM. And it'll actually give you what's actually inside the image. So they release the images as tarballs, and it's going to give you an actual SHA-256 of all the contents of that image. So if you wanted to go even further or do runtime validation on the node itself that's running that image, you can go ahead and do that. The image has been signed and not tampered with, and the SHA-256 of all the contents. contents inside it. So I think that's the end of my 5 minutes. Thank you.